In this video, we're going to talk about what are called measures of relative standing. So what this means is where the data values lie with respect to the other data values in the data set. Okay, so we're going to look at these 12 data values: 3, 13, 33, 50, 53, 57, 60, 72, 76, 77, 80, and 92. And we want to learn the concept of a z-score. So the z-score is a score for each individual number. So the z-score of a value is the distance it is from the mean, meaning that data value is from the mean, measured in standard deviations. So we're saying how many standard deviations is this from the mean? And this will be a positive or a negative number, and a relatively small number. So the symbol for the z-score of x is z of x. In the formula, you take the x value, you subtract the mean of the data set, and you divide by the standard deviation. So for this data above, so I've put all of those data values in L1, and I'm going to go stat, over to calc, do the one variable stats, and we see our mean is 55.5, and our standard deviation is 27.3. So the z-score, when we see z50, that's the z-score of 50. So that's our x. So we take x minus our mean, 55.5. I meant to put a 50 in there instead of the x. Divided by our standard deviation, 27.3. Now if you're doing this in the calculator, make sure you put parentheses around the numerator. So we'd have 50 minus 55.5, and we would divide that by 27.3. So here we always round to 2 decimal places. So here it's negative 0.20. Now this is a negative z-score because 50 is below the mean. It's lower than the mean. If we want the z-score of 77, we would take 77 minus the mean and divide by the standard deviation. So again, in our calculator, make sure you put parentheses around the numerator. So our z-score here would be 0.79. 0.79. Again, that's a positive value because 77 is bigger than the mean. Now, just like we talked about usual and unusual values, we can use z-scores to determine that. So a data value is unusually large if its z-score is larger than 2. So if z of x is greater than 2, then x is unusual. And it's unusually small if the z-score is less than 2. Sorry, less than negative 2. So if z of x is less than negative 2, x is unusual. I did not spell unusual right. Okay. Now another way that we can, so the z-score lets us know how far away from the mean a data value is. The other way we can talk about kind of where data values is, or talk about percentiles. Okay, and percentiles happen all the time in the real world. When you go to the doctor or you take your kid to the doctor, you may be told that their height is in whatever percentile. Or if you take a standardized test, you'll be told your score is in whatever percentile. So the way that we create percentiles is you divide the data into 100 groups, so each of those would be a percent, with 1% of the values in each group. And the symbol for the 72nd percentile or whatever, it's a P with that number. My one disappeared. Okay. Now, what a percentile means, if you're told that you're in the 72nd percentile, let's say for height, that means that 72% of people would be shorter than you, are less than you. So if you're told you're in the 80th percentile for a standardized test, that means that you scored better than 80% of the people. Okay, so here's how we can actually find them. So to find the percentile of a certain value X in a data set, you first want to order them from smallest to largest. And to find the percentile, you count the ones that are less than, you don't include the numbers that are that number, divide it by the total, and then multiply by 100. So here we have 12 data values, and we want to know 50 is in which percentile. So we count how many are less than 50, which would be 3. We divide that by the total number 12, and we multiply by 100. So here we're going to get 3 divided by 12 times 100, and we'll see that we're in the 25th percentile. Okay, if we want to know what percentile 77 is, so we'd count how many are below 77. So we count those up. There's 9 of them. Do 9 divided by 12 times 100. And we'll see that we get 75. So this is the 75th percentile. Now, if you want to kind of know in your data set what would be the cutoff for a certain percentile, we use what's called a locator value. So let's say, the locator, you take the percentile you're trying to find, divide that by 100, and multiply it by the number of values in your data set. And then you always round up. So this says find the data value from above that corresponds to the 67th percentile. So to find our locator, I'm just going to call it L. We take our percentile, the 67, divide that by 100. That just turns it to a decimal. And remember, we had 12 data values, so we're going to multiply that by 12. So if we take 67 divided by 100 and multiply that by 12, we get 8.04. Now on these, you're always going to round up. So we're going to round up to 9. So we would go to the 9th data value. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 76 would be the data value that corresponds to the 67th percentile. Now, percentiles are actually going to come in to what we call quartiles and the 5-number summary. So quartiles are just, instead of dividing it into 100 groups, we're only going to divide the data into 4 groups, where 25% of the data is in each of them. Okay, so you'll see those in the 5-number summary. So here's the data value, and that's actually the data we've already used, so it's actually already in our L1 for us. We're going to find the 5-number summary. Now, whenever you're asked for the 5-number summary of a data set, it includes these 5 numbers. The minimum value, the minimum X, the first quartile. Now that's the same as the 25th percentile. So a quarter in, what's the data value? The median, which we've talked about how to find the median, the exact middle value. Now that's actually the same as what's known as the second quartile or the 50th percentile, what's exactly in the middle. Q3, the third quartile, is what's 75% of the way through the data value. So that's the same as the 75th percentile. And then the maximum value. Now the good news is that the calculator is going to give all of these to us. So if we hit stat, go over to calc, one variable stats again. So if we scroll down, it will give us minimum, Q1, median, Q3, and maximum. So we're going to write down for this data set 3, 41.5, 58.5, 76.5, and 92. And we can make what's called a box plot, kind of a special graph. Another name for this is the box and whisker plot. For these numbers. So it's always made beside a number scale, so above, it doesn't matter how much above. You don't make it exactly on the number scale. So for this data set, we're going to go to about where 3 is. You kind of have to guess. And we put just a vertical line. Q1 was at 41.5, so we go to about 41.5. Guess where it is? The median's at 58. Q3 was 76.5. And the maximum is 92. So we draw little vertical bars for each of those. The box from Q1 to Q3, we draw a box. So the median's in between. So these middle 3, we draw a box. And our whiskers go out to the max and the min. So it's just a box and it has these 2 lines out to the max and mins. Okay, and we'll see why these are sometimes helpful. So you can use box plots to compare 2 data sets. Okay, now if we were in a classroom setting, I would have you find the 5-number summary for the men's heights, which are here, and the women's heights, which are here. So what I recommend you do here on the video is pause the video right now and find those 5-number summaries. Okay, I hope you did that. And I'm going to tell you what they are so that you can compare your data. So for the men, the minimum is 63. Q1 is 66.2. The median is 68.9. Q3 is 70.6. And the maximum is 76.2. And the women's 5-number summary, 58.6, 61.4, 63, 64.3, and 66.8. And now we would draw these 2 box plots. Now the women you can draw right here, kind of at this level, and the men's above it. So we'll go do the men's first. So about 63, 66, 68, 70.6, 76.2. And for the women, we've got 58.6, 61, 63, that's probably not, 64.3, and 66.8. Now, since these were drawn with the same scale, we can see in general, and you can write some of these thoughts down, that women are overall shorter. And their heights are less spread out. So that we talked about the percentiles and how those relate to the 5-number summary.